Okay, so good afternoon. Today we're looking at the day 2 of 5.1, and what we're doing is example 6. We're solving trig equations. But keep in mind as we're doing this, during solving trigonometric equations, simplifying expressions and or rewriting them in more useful equivalent expressions is very helpful when trying to solve trig equations algebraically. So I'm going to be looking at this one right here, and notice the interval. Because the unit circle starts repeating itself at 2 pi, I'm really interested from 0 all the way around to almost 2 pi because 0 and 2 pi have the same values. So that's why it's not included in that interval. Okay, so now when I'm going to solve this, I've got cosine 3x all over sine x, and I'm going to, this equals cotangent x. Well, keep in mind cotangent x is the inverse of tangent, and tangent sine over cosine, so cotangent's cosine x over sine x. And this is cosine 3x over sine x. So I'm at this point, I can drop the sine x's since they are the same, and to know that I can just take them out, but I have to look back at them for restrictions later when I've finished solving the problem. So now I've got cosine 3x minus cosine x as well. That equals 0. I put everything over to the side with a division of sine x, and really if you want to look at that, or a multiplication of sine x on both sides, and then adding or subtracting the cosine x. But now I've got cosine x times the quantity cosine squared x minus 1 equals 0. Well, this is the difference. This here is the difference of two squares. Okay, so I want to make sure I keep that in mind, and I'm going to break it down a little further. Because cosine x minus 1, and cosine x plus 1 is equal to 0. Now, I'm going to find where cosine x is equal to 0, and cosine x is equal to 0. As I'm spinning around here, cosine x is equal to 0 at pi over 2 and negative pi over 2. So pi over 2, I've got 0, 1, and negative, not negative pi over 2, 3 pi over 2, I've got 0, negative 1. Okay, so those are values of x there. Here, cosine x minus 1 equals 0 when cosine x is equal to 1. And cosine x plus 1 is equal to 0 when cosine x is equal to negative 1. So I'm going to be thinking about where cosine x is 1 and negative 1. Well, cosine x is 1 at 0 because that's 1, 0. And it's also 0 at negative 1, 0. It's negative 1, excuse me, at pi it is negative 1 and 0. I was just thinking about what my sign restriction is at that point. And now I got to consider the fact that right now I have the solutions, and the solutions to the equations right now is I've got x is equal to 3 pi over 2 and pi over 2. So I got pi over 2 and 3 pi over 2. And I just found that it could be 0 and pi, but keep in mind, at 0 and pi, these values, when I put that in for sine x, it makes it 0. And so I can't have those be answers for this problem because it makes the original 0, so it's as undefined when sine of x is 0. Okay, those don't work because it's undefined, and their answers would be extraneous, so they would not be included in our final answer. So the values of x are going to be pi over 2 and 3 pi over 2. Now, as we move on here, we're looking at example 7. And in 7, we're going to break it up in a couple different steps. Again, we still have that interval, so it includes 0, but it's all the way up to 2 pi, but not including 2 pi. So now I'm looking at 2 sine of 2x plus sine of x equal 1. And if I get it, so everything's on the left side, it kind of looks like it's 2x squared plus x minus 1. So that's basically what I'm going to be factoring with signs in as my x value. So I have 2 sine x and sine x. That'll give me my sine x squared. And I need a 1 at the end, so I got 1 and 1. And one of them's got to be negative, one's positive, so the bigger one's going to be positive as I multiply with the 2, and that one's negative. So now I'm saying that 2 sine x minus 1 is equal to 0, and 2 sine x equals 1, and sine x equals 1/2. Well, where is sine 1/2? If I spin around, sine's 1/2 there and there at pi over 6. Okay, I've got the square root of 3 over 2 and 1/2. And at 5 pi over 6, I've got the negative square root of 3 over 2 and 1/2. So my sine is 1/2 at x being, then I'll put those answers down here, x is equal to 5 pi over 6 and 5 pi over 6. Okay, for that first one. My other one I've got to consider is I'm looking at the idea that sine of x plus 1 is equal to 0. So when is it sine of x equal to negative 1? Well, sine of x is negative 1 at 3 pi over 2. So if I'm looking at 3 pi over 2 and I'm going around here, that's pi over 2. That's 0, 1. And this is 3 pi over 2. And that's 0, negative 1. Well, that's where it's sine of x is negative 1. Remember, it's a ratio returned. So I also got 3 pi over 2 as one of my solutions as I'm stepping through. So remember, and I've got those 3. And that is 3 solutions that exist for this function in the interval from 0 to 2 pi. Now let's answer question B here. Find all solutions to the trigonometric equation. That's that. Well, it's the same question. Right now, I know that x is pi over 6, and x is 5 pi over 6. And I also, from the other side, I'm just going to put it in a different color the way I did it, 3 pi over 2. But what I want you to be aware of is that every time I go around the circle, every 2 pi, I get back to a coterminal angle with pi over 6, and a coterminal angle I can come back to from 5 pi over 6 every 2 pi rotation, and 3 pi over 2. So when I'm doing these, you got to be thinking when I'm asking for all solutions, I've got to add in multiples of 2 pi, or I'm going to say 2n pi, where n could be any value that is an integer. Okay, so we're going to talk about that being part of the set of integers here. And so each one of these is where, let's get a better where, not when, but where n is contained in, that's what that means, contained in the set of integers. Let's put it in Z set, okay? And that would be the solution complete with that. Okay, so that's all solutions for the trig equation, 2n squared x plus, 2 sine squared x plus sine x equal 1. Now going on the problem, our next set of problems, we have several, this rapid fire, and I want you to try them by yourself before you look at the solution, and make sure you can work through them and find your solution for them, and I'll work them, but make sure you do them first and then check your solution. This is, enough right now to actually kind of get pushed out of the nest a little bit and try your flight wings and see how it works. So we're going to talk about rapid fire, and we're just going to get this going. So you try it, turn me off, you try it, and then turn it back on and see what happens. Okay, welcome back. We're looking at the idea that I'm going to subtract the square root of 3. So I've got 2 sine x is equal to negative square root of 3. I divide by 2, and I sine x is equal to negative square root of 3 over 2. Now, we're asked to find it in the range from 0 to 2 pi, so I'm not going to have multiple revolutions here. So when I'm looking at this problem, I'm actually trying to figure out where in the world on the unit circle do I have negative square root of 3 over 2. In both of those situations, I got a negative square root of 3 over 2. They both happen to be something's over 3's for pi. So if this is 3 pi, 4 pi, and 5 pi, so I got 4 pi over 3, and I'm going to have 5 pi over 3 as well. So x is equal to 4 pi over 3 and 5 pi over 3 for those two to be a solution. Now, turn it off again, try B. Okay, so we're trying B, we got to divide by 4, and we got secant squared x is equal to 2. I'm going to take the square root of both sides with secant, and I've got secant x is equal to plus or minus the square root of 2. And now remember, secant is the cosine, inverse. So 1 over cosine x is equal to plus or minus square root of 2, and cosine x is equal to plus or minus 1 over the square root of 2, which is the same as the plus or minus square root of 2 over 2. Plus or minus the square root of 2 over 2. Well, when is cosine ever the square root of 2 over 2 plus or minus? Well, every pi over 4 you can think of. And I got to pull this over a little bit because I'm using too much space. So x should be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 as we step through those, because each one of those is a solution to this particular problem. Now on the next one, if I would like you to go ahead and turn it off again, give it a try and see how things go, and we'll just work and step through as you're going. Okay, welcome back, and we've got 4 cosine squared x equal 3. I'm going to divide by 4, and I got cosine squared x equals 3/4. And now I'm going to take the square root of both sides, so I have cosine x is equal to plus or minus the square root of 3 over 2. Now I've got to think about, where do I have plus or minus the square root of 3 over 2 for cosine? And that is at x pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 as we step through those. So keep in mind as we're going through, that unit circle is golden, making sure that I can recall everything. Now, part of that golden unit circle is thinking about, when is sine of x and cosine of x the same? So I'm asking really those x and y coordinates, they got to be equal. When are they ever equal? And if I'm looking at the unit circle, I'm looking at this, they're equal here and they're equal here. At pi over 4, they're the square root of 2 over 2 and the square root of 2 over 2, so they're the same. And at 5 pi over 4, okay, that's 1, 2, 3, 4, and that's 5 pi over 4. And this is at negative square root of 2 over 2 and negative square root of 2 over 2. They are not the same in quadrants 2 and 4 because they're opposite in sign. So in letter D, our solution for x is equal to pi over 4 and 5 pi over 4. Okay, go ahead and turn it off and try E. Welcome back again. We're looking at the idea that I've got 2 cosine squared x minus cosine x, because I'm going to subtract that from both sides. Now I'm going to factor out a cosine squared x, or not a cosine squared x, but a cosine x. So I have cosine x times 2 cosine x minus 1. Okay, equals 0. Now I got to figure out, using, again, that's what we've been doing, is zero product rule. When is this going to be 0? So when's it 0 is cosine x is equal to 0 when, if I'm looking around, I've got pi over 2, and that's 0, 1, and 3 pi over 2, and that's 0, negative 1. So at pi over 2 and 3 pi over 2, it's going to be 0. So that's 2 answers right there. So x is equal to pi over 2 and 3 pi over 2. Now, the other thing where it's going to be 0, if I got 2 cosine x minus 1 equals 0, and 2 cosine x is equal to 1. Get an x in there. And so cosine x, after I divide by 2, is 1/2. Well, where's cosine x 1/2? It's right there and right there. So I'm at pi over 3, and that's right there. And I also got 5 pi over 3. That's right there. So I'm at pi over 3 and 5 pi over 3 for my solutions as well. Now, as we're going on to F, we're going to make sure that we still kind of follow along what's happening, but it's hard to factor when I have two different trig functions. So I'm going to use the idea that sine squared x is equal to 1 minus cosine squared x. So I've got 2 plus 2 cosine x equal 1 minus cosine squared x. So I'm using the Pythagorean identity here. And so I'm going to add cosine squared x, okay, and plus 2 cosine x. And I'm going to add or subtract a 1, so negative 1 and 2, and so it's going to be plus 1 equals 0. Well, this is a perfect square. So I've got cosine x plus 1 times cosine x plus 1 equals 0. And I'm just going to move that over a little bit so I can get my equal 0 in there. And that's going to be cosine squared x and 2 cosine x and 1. So I'm just double checking with FOIL. And now, where is this going to be 0? Well, cosine x is equal to negative 1. Well, when cosine x is negative 1, where is that on our unit circle? So if I got cosine negative 1, I'm out here at pi. So that is my only spot, and I'm going to add that back into our solution. Actually, I should add it back into the solution. It's the only part of our solution in letter F. X is pi. So let's make sure that we know where those solutions are on each one of these on the bottom. Okay, and we got these guys here, and we got these guys here. And we're floating around with these. I got that boxed in, and we're going to box in this one for that top one there. So make sure you're keeping in mind what's happening with these. Be real patient with yourself, but keep in mind we are still working pretty heavily with that unit circle. And if you're not very comfortable with it, it makes it more difficult. So make sure you're going to be covering that. And I hope things are going well. Have yourself a great day.